Hi there, welcome to my tutorial on converting from standard form to a normal number. What we've got here is we've got a number in standard form, 2.3 times 10 to the 4. And I want to write that as a normal number, as an integer. So what I'm going to do is I'm going to use this little grid for the first example, just to show you what's actually happening. We're not going to use the grid all the time, but just to show you how this actually works. I've got my number 2.3 here, and I'm going to times this by 10 to the 4. Timesing something by 10 to the 4 is the same as timesing something by 10 times 10 times 10 times 10, which, if we work that out, there's 4 zeros there, gives us the number 10,000. So we've got to multiply 2.3 by 10,000. If you're multiplying something by 10,000, what we're in effect doing is we're moving the digits 4 places to the left. So that ties in to the power here, raised to the power of 4. We're going to move our 2.3 4 places to the left. And this is why it helps using this grid. I like to fill in a few zeros either side of my 2.3. That's going to help us. But we're going to move all of these digits 4 places to the left. So if we take the 2, originally it was here. We're going to move it 1, 2, 3, 4 places. So that 2's going to move to there. The 3 is going to move 4 places. 1, 2, 3, 4. Going in front of the 2. And then all these zeros are going to move 4 places as well. So we're going to get our answer 2, 3, 0, 0, 0, 0.0. We don't have to write the 0.01. It's always a good idea to check if we've done this right. Convert it back. If we're converting it back, we put our decimal here and see how many places I'd need to move it to get to the end. If the decimal goes there, we're going to move it 1, 2, 3, 4, which ties in to the 4 that we raised the 10 to the power of. Okay, let's have a look at the next example, e.g. 2. 4.8 times 10 to the 3. Now I'm not going to use the grid for this one. I've just got to realise that all my digits are going to be moved 3 places to the left. So I write 4, 8, 0, 0. It's always a good idea now to check whether we've done it correctly. So if we put the point in here, are we going to be able to move this 3 places to get to the end? 1, 2, 3. Yes, we are. So 4.8 times 10 to the power of 3 is the same as 4,800 as an integer. Let's have a look at the third example here. Here we're raising this to a negative power. So this time, if we're raising it to the negative power, we're basically dividing it by 10 to the 2, or 100. So this time we're moving our digits 2 places to the right. So we can do it again here. We've got in this table 4.2 is what we started with, but we're now going to be moving these 2 places to the right. So if we fill in a couple of zeros there, and I'm going to move now my 4 2 places. So put my decimal in there. 4 goes 1, 2 places to the right, moves to there. The 0 here is going to move 2 places, goes to there. This 0, 2 places, goes in front of the decimal point. And the 2 here, we're going to move this 1, 2 places to the right, and we get our answer of 0.042. Let's check again to see if it ties in with this negative 2 here. The point is there. If we move this 2 places to the right, 1, 2, does it get us to the 4.2? Yes, it does. So our answer there is correct. Let's try this one without the grid this time. We've got 5 times 10 to the negative 4. So basically, if we write 5.0 to help us, we're moving our digits, the 5 and the zeros in front of it, are going to be moved 4 places to the right. So if we put in a couple of zeros in front to help us. We're going to move our 5 4 places to the right. We're going to move these zeros 4 places to the right. So I'm going to get 0.0005. I've moved my 5 4 places to the right. Let's just check to see whether if we convert back, we're going to get to our -4. The decimal's there. We want the decimal to be after the 5. 1, 2, 3, 4 places. So 5 times 10 to the -4 gives us as a number there 0.0005 as its normal number.